In this video, we're going to talk about another type of transformation. We're going to talk about stretching and shrinking graphs. Some books will use the term dilation instead of stretching and the term compression for shrinking. But essentially what we're doing is pulling the graph away from or toward one of the axes. So this can be in the horizontal or the vertical direction. So in the equation, we'll know we have stretching or shrinking because we'll see multiplication. So we saw in a previous video that shifting comes from adding or subtracting. And we also saw that reflections come from multiplying by a -1 somewhere in the equation. Stretching and shrinking is going to come from multiplying by a number other than -1. And of course, we're not going to multiply by 1 or 0 because that would not make a whole lot of sense. But if we're multiplying by any other number, then we're going to have either a stretch or a shrink in the graph. So let's talk about the vertical direction first. So remember that when we have a vertical change in our function, that comes from doing something outside of the original function. So you can see here we're multiplying the original function on the outside by some constant. And if the constant is greater than 1, that's going to cause a stretch in the vertical direction. So the graph's going to get pulled away from the x-axis. And if the number is between 0 and 1, that's going to be a shrink or compression. So the graph's going to get squished toward the x-axis. And so any points on the x-axis will stay the same, but the rest of the points on the graph will change. So we're going to illustrate this here with our basic x cubed function, and then we're going to do a stretch and a shrink in the vertical direction here. So if we substitute these three x values into our x cubed function, then we have these y values, and so then we can draw that graph. Okay, so there's our x cubed function. Now if you think about what would happen if we substitute each of those same x values into the next function, y equals 2x cubed, you're going to cube the number first, right, and then multiply by 2 at the very end, because the 2 is outside of the cubing, it's outside of the original function. So essentially when you cube the x value, that's going to give you the value that we had on the original, the y value. And then we're going to multiply that by 2. So essentially you can take these y values that we got here and just multiply them by 2, and that will give us the points that we'll have on the stretched graph. So then if we plot those, what we're seeing is they have the point 0, 0 in common, because that's on the axis that we're stretching away from. But then the point that was at 1, 1 gets stretched up to 1, 2, and all the other points in quadrant 1 will get stretched up. And then similarly in quadrant 3, everything's going to get stretched away from the x-axis as well. My drawings are not the best on here, but you get the idea. Okay, and then the last one is going to give us a compression or a shrink because the number out front is between 0 and 1. And again, we can just multiply the y values from the original graph by 1/2, and that will give us the y values on the transformed graph. So if we do that, we have these y values. And so again, we still have the point 0, 0, but then everything in quadrant 1 is going to come down because it's getting shrunk toward the axis, and everything in quadrant 3 also gets shrunk toward the axis. So the graph's going to look something like this. So when we do transformations, the y direction behaves nicely is how I like to describe it. You may have noticed this with the shifting that we did. If we want to shift up, we see a +4 or something in the equation, and then to shift up 4 units, you can essentially just add 4 to the original y value. And then here we saw the same for the stretching and shrinking. We can just multiply those original y values by the stretch factor, and that gives us the new y values. The horizontal direction does not behave quite that nicely, and again, you might have noticed that when we did the shifting, because when we did the shifting, the equation said x minus 3, for example, if we wanted to shift 3 units to the right. Well, if you want to shift 3 units to the right, you're actually increasing the x value. So the x direction almost seems backwards to many students, and so we're going to have to keep that in mind when we do our horizontal stretching and shrinking as well. But I'm getting a little ahead of myself here. Let's talk about what the equation is going to look like. So we still see multiplication by this number c, but now it's happening inside the function with x. So you can always tell when it's a horizontal change because it's with x, and x is your horizontal axis, right? That's the x-axis. Now we're actually going to have a stretch in the horizontal direction if the number is between 0 and 1, and a shrink if the number is greater than 1. So again, we're seeing that the x direction often behaves kind of backwards from what we might expect, but that's the way it works out. So let's take our basic square root function here, and I'm just going to pick some x values that will give us nice integer y values here. Okay, so there's our original. And we're going to do a horizontal stretch and a horizontal shrink. So now that it's horizontal, we're not looking at stretching up and down away from the x-axis. We're looking at stretching away from or toward the y-axis. So the stretch is going to pull it out this way. The shrink is going to push it back toward the y-axis. So if we make this then square root of 2x, for example, if we want to graph this so that we can see the result of that stretch or shrink, what we need to do is actually plot points that have the same y values that we did before, because we didn't change anything in the vertical direction. So if we are looking for the 3 corresponding points at the end of this transformation, they're going to have the same y values because we don't have any vertical transformations. So what we can do then is figure out what x values now would give us the same y values that we had before. And so you might be able to tell just by looking, or we can set up an equation to figure that out. So for example, if we want to take the square root of something and end up with 0, we need to take the square root of 0, right? So the stuff under the square root needs to be equal to 0. And so for this point, x is still going to be 0. And again, that's because the point 0, 0 is on the axis that we are stretching away from or toward, shrinking toward. But if we look at the next point, for example, now we want the square root of 2x to be equal to 1. So in other words, we need to be taking the square root of 1, right? That's what was happening here. We took the square root of 1 to get that y value. So we need to have a 1 under our square root. So in other words, 2x has to end up being 1. So then we can figure out, well, what should we plug in for x then? Oh, 1/2, right? If we plug in 1/2 for x, we'll have 2 times a half under there, which is 1. And then similarly, to get the last y value, that's a 2, so we took the square root of 4, right? That was our original x value. We still want to take the square root of 4 here, but now that means that 2x has to come out to be 4. And so that would require an x value of 2. So by plotting these points, we can see the transformation now. The point that used to be 1, 1 is now at 1/2, 1. So same y value, but the x value is smaller. And then similarly, the point that was 4, 2 is now 2, 2. So we've shrunk toward the y-axis here in the horizontal direction. So this is a horizontal shrink. So that's why a number greater than 1 gives us a shrink this time, because we end up, in this case, dividing by 2 right on both sides to solve each of these equations. So we've cut all the x values in half, which is why it gets shrunk toward the y-axis. Okay, so let's do a horizontal stretch then. So for that, we're going to need to multiply by a number that's between 0 and 1. So we'll make this square root of 1/2 x. And again, to see the horizontal change, we need to keep the y values the same, and then just figure out what do the new x values need to be. Well, the first point is still going to be 0, 0, because again, that's on the axis we're stretching away from. And we can see that putting in 0 for x would give us that y value of 0. But now, again, for the second point, we need to be taking the square root of 1. So the stuff under the square root needs to equal 1, because that was originally what was under the square root in our original function. So we need 1/2 x to be equal to 1. And so if we multiply both sides by 2, that helps us find the x value. And then similarly, for the last point, we took the square root of 4 the first time, and so now we need to also take the square root of 4 again, and so that means that 1/2 x needs to be equal to 4 for this point, and so then x needs to be 8 for that last point there. So this time we're starting with the blue graph and we're stretching it away from the y-axis, because the point that was here at 1, 1 is now at 2, 1. The point that was here at 4, 2 is now out here at 8, 2. So the graph got pulled to the right horizontally away from the y-axis. So that's why it's a horizontal stretch.